Hello dear students. After learning basics of Printf in the previous video and some escape sequences, in this video we will be learning about variables and data types. Every C program contains variables. Variables are nothing but quantities. Variable is nothing but it is a quantity which can change during execution of the program. Anything which can change. It's a quantity which can change during execution of a program. A very good example of variable is in a computer game, score is a variable. In any computer game, score can be a variable because score increases when we do some good move in a game and decreases otherwise. Like that, in almost every program of C, there has to be a variable. Variables are nothing but placeholders. Variables are nothing but placeholders to store some value. Variables simply store a value. That's it. Now, every variable must have name. We will call a variable by its name. There are some rules for naming variables in C language. Name of the variable must begin with an alphabet, A to Z, any of these letters, or it can start with underscore. Sorry for the spell mistake here. Underscore, which is an underline character. After the first letter, there can be any combination of alphabets, digits, or underscores. Just go through this rule again. Pause the video and go through the rule again. First letter has to be alphabet or underscore, and after the first letter, there can be any combination of alphabet, digits, or underscores. Following are some valid variable names. Let's see some variable names which are valid, like A. Now, this variable name begins with alphabet and it may be followed by alphabets, digits, or underscores. It is not followed. So, simply A is a valid variable name. A1, it begins with alphabet followed by digits or underscores or alphabets. Check this. Roll underscore no begins with alphabet followed by more alphabets, underscores, more alphabets. Check this last one. It begins with alphabet, that is D. It begins with D, alphabet, followed by more alphabets or underscores, digits, underscores, followed by more alphabets. Any of these are valid variable names. Now, following are some invalid variable names. Let's see 1A. You can't name a variable like this because it is beginning with a digit. Notice that a variable must begin with alphabet or underscore. Similarly, AB comma CD, check this is not a valid variable name because comma cannot appear inside a variable name. In a variable name, only three things can appear: alphabet, digit, or underscore. Now, A star B, this also is invalid, isn't it? Because star, that is asterisk symbol, is neither an alphabet, nor a digit, nor an underscore. Let's see more examples. A dash B. A dash B cannot be a variable, cannot be a variable name because dash is neither an alphabet, nor a digit, nor an underscore. So all these are invalid variable names. So once we have seen what is a variable is a quantity which can store some value and it can change during execution. Let's see the another concept called data type. Now every variable in C language is associated with some data type. Data type is no way a very complex word. Data type is nothing but type of data. So you are having a variable. Definitely that means you are storing some value in that variable. Which type of value you that is defined by data type. Every variable definitely has a data type. Now, as far as C language is concerned, these are the basic data types. These are the basic data types in C. Int, which stands for integer data type. This data type can hold only integer values. For example, 22, -3, 0, but you can't store a value like 3.5, which is a real number in int data type. variable. Float is the another data type which deals with real values. This data type can hold floating point numbers. Check that, like 2.2, minus 5.5, 0.0. Now there is another data type called double, which also deals with real values. So actually float and double both are same. Both are actually same, but double deals with larger floats and it also has better accuracy, better precision. So it is same as float data type, but it can hold larger values and of course smaller values also, and also has higher accuracy than floats. The last one is char, which stands for character data type. This data type can hold a single character, such as A, Z, dash, 2. Now notice, dash is a character or 2 is a character. Many of you might think that 2 is a digit. But if 2 is enclosed, if 2 is enclosed in apostrophe, I'm so sorry for this. If 2 is enclosed in single quote, just check this. If it is enclosed in single quote, in that case, 2 becomes a character. Similarly, if I give quote and if I give let's say greater than quote close, single quote obviously, then this greater than symbol becomes a character. Any such single character can be stored by this char data type. So basically, as if you are asked what are the basic data types of C, there are four basic data types: int, float, double, char. We will learn more about this, like what is their range, what is the range of each data type, how big, how small values they can store, and what is definitely the memory requirement. So int consumes how many bytes, floats consumes how many bytes, in the coming videos. But let's see this code. In this code, in this hash include stdio.h. So sorry, I have missed int main here. After hash include stdio.h, it has to be int main. Pardon me for this. Int main. And then brace open. So let's see this simple code where I have declared one variable a. Now this is the declaration of a variable. Variable a is of type int. Now it is so important that variables must be declared before their use. So if you have a plan of using a variable a later in the program, must be declared before it is used. Now int a means declaration. A is a variable of type integer and we are storing a value 10, which is integer value, isn't it? In this variable a. The next line simply increases a by 5. So a becomes 15. Now the last line of this code is printing the value of it. Oh, I'm so sorry. I have not even written in this code return 0. So just check this. Just pardon me for this. Here we should have int main and here we should have return 0. Okay, fine. Now you just check this printf. Printf percent %d a. We have to now discuss about this printf. Now just check. My aim, my goal, is that whatever is the value of a, I want to print it on the screen. So a beginner might think that why don't we give printf like this? Printf and whose value we want to print? A. So let's give quotation and a. Now you can easily understand if I give printf like this, then the output of this code will be simply letter A, because whatever is given inside the quotation is printed as it is. So this is going to print A and not the value of A. So how do I print the value of A? To print the value of A, coming back to this printf, I have to use some format. This is known as format, and formats of printf begin with %d or %f or %lf or %c, depending on which type of value are you printing. Now %d is the format used for printing decimal value. D stands for decimal, and A, which is having a value 15, is definitely a decimal number. So this printf can be read as A should be printed in decimal format. I'm sure you might not have understood if you are really a beginner, which I don't think so, because you are appearing for GATE and definitely you must be in third or fourth year, or maybe you already passed out engineering. So all these are really very basic things I am explaining. But my suggestion is that you go through these videos although, or you can fast forward it and just go through these videos. I would like to explain this printf going back to this editor, Atom, and here is that program that I have written. Here, a is of type integer, it's a variable and its value is 10, a becomes 15, and this printf is printing the value of a. Let's say that I print a in this way, giving it in quotation. In that case, when I compile and run this program, it's going to give me letter A, isn't it? Because we know whatever is enclosed in the quotation is printed as it is. So the output, it's taking too long. Output is A, but I don't want A, is it? I want value of A. So just go through this very carefully, what I am saying, and you will never forget the basics about printf. Now, how do you print value of A? First of all, you want to print the value of A. So in the printf, you give A. You want to print value of A. So you give printf A. Just before A, you give comma, and just before comma you give the format. Now printf, the problem with printf is a very lazy statement. You have to tell printf whose value are you printing. Now you are printing value of A, so that you have already specified, but you have to also tell printf which type of value are you printing. Now you are printing the value of A, and A is a decimal number, so you will have to say I want to print A as a decimal number. Let's remove these additional spaces, and this becomes the printf. So the printf statement can be easily read as print value of A in decimal format. So hence, when I run this code, the earlier one was simply printing letter A. When I run this code, this is going to print, this is going to print 15. That's the value of A. Now, something interesting. What if I don't want to print A as a decimal number, but I want to print A as a octal number. Now I guess gate students would know difference between decimal, octal and hexadecimal. Like here A is 10, which is a decimal number, but the octal equivalent of this, you can check it, is 12. So if I want to print this in octal format, I would give %o. So I am just printing the same A whose actual decimal value is 10, but I want to print it in octal format, so I will give %o format. This can be now read as print value of A in octal format. Let's try to compile and run this code. So this time 17 is the octal equivalent of 10. Okay. So now what if I want to print the same decimal number 10 in hexadecimal? So I will give %x as the format. This time printf can be read as print value of A in hexadecimal. And now everybody knows, come on, I won't go wrong this time. Hexadecimal equivalent of 10 is A, isn't it? So when I run this code, compile and run this, it's going to print something wrong. Oh, I'm so sorry. A has become 15 here. Yeah. Oh, I got lost. A has become 15 and hexadecimal equivalent of 15 is F. So it's right. F is the hexadecimal equivalent of 15. So what you are watching here is that printf must be told whose value you want to print. So you should give variable. Just before the variable, you should give comma. And just before the comma in the quotation, you should give the format. Coming back to %d format, coming back to this, now, what if I want to print the output as A equal to and then the value of A? So simply inside this, I will give A equal to. Now you see that A equal to has been enclosed in the quotation. So it will be printed as it is. And this %d is going to print the decimal equivalent of A. So the output of this is going to be A equal to 15, isn't it? Yeah. So one more code, let's see, one more code where we have mixed up all the data types which we saw in the text earlier. Here I have declared one int variable whose value is 10, float variable 4.3, double variable which can store larger values. Z is a double variable, but it is storing an ordinary value 16.76, and then a char variable W whose value is a. Now notice that any character constant must be enclosed in apostrophe open and apostrophe close. Now let's see, how do you print the value of x? Now x is a decimal number. So value of x equal to %d format has been given. Backslash n has been given so that new line is produced and all these outputs will be produced on new lines. X is the value. Similarly, %f format is used for float, %lf is used for double. Now, double is often called as long float. It's a bigger float. So it's so easy to remember the format. %lf means long float and %c means character. So these are the formats for meant for printing the required variables. Let's try to run this code and check the output. Output of this would be value of x is 10, y is 4.3 and so on. Check that w is a. Let's say I put this here instead of %f, I put %e. This is a very interesting format, %e. Now %e is often used for printing floats. Now you know that y is a float, isn't it? Y is a float, and you know to print a float you use %f, but often you use %e. Now %e is exponential format which contains two parts, mantissa and exponent. Now notice y is 4.3. It will be printed as 4.3 E0. Now E0 means 10 raised to 0. So 4.3 will be multiplied with 10 raised to 0. Okay, let's see. Let's run this code and see what output does it produce. Compile and run. You can check that the output here is 4.3, some zeros, and then E plus 000. Now, E plus 000 means this value 4.3 multiplied by, E means multiplied by 10 raised to 0. 10 raised to 0 is anyway 1. So 4.3 is the answer. By the way, let's try again. I'll change this code. I'll change this value to, let's say, 48.3. Now the output of this code will be, let's compile and run. The output of this code will be 4.83 into E into 10 raised to 1. So 10 raised to 1 is 10. So 4.83 into 10 is 48.3. The same format %e can be used for floats also. So for both floats and double, we can use %f, %lf or %e format. So this was a bit bigger video where we have seen various data types and various formats %d, %f, %lf, %c for printing the variables of the corresponding data types. Thank you very much.